Hi everyone, so today we are going to be looking at the IGCSE homologous series, including alkanes and alkenes and their properties and how to distinguish between them. So firstly, what is a homologous series? Each family is a series of organic substances that contain closely related compounds. Molecules in the same series will have similar properties, but as molecules get larger, the properties will change, such as the melting point, boiling point, viscosity, but we'll cover those later in the video. So now we're going to look into some similarities and how to name the different series. So for example, the prefixes throughout the series will be the same. For 1 carbon, it will start with meth. For 2, it will be eth. 3, prop. 4, bute. 5, pent. And 6, hex. And these are the 2 homologous series we're going to look at today. For the alkane series, the suffix would be ane, and for the alkene series, the suffix will be ene. So now we're going to start by looking at alkanes. So alkanes are saturated hydrocarbons. This means they have a single carbon-carbon bond. And the general formula for alkanes is CnH2n plus 2, n being the number of carbon atoms, which has to be greater or equal to 1. So let's look at 4 examples in the alkane series. So first of all, CH4. We have 1 carbon atom, so we know that the prefix is going to be meth, and the suffix for this series will be ane, so we have methane. So to draw the display formula for that, 1 carbon atom can bond to 4 hydrogen atoms. So we have 1, and it can bond to 4 other atoms. Now we'll look at the next one. So the molecular formula is C2H6. If we look at our prefixes, for 2, we have eth. So that gives us ethane. And for the molecular formula for this, we can do the same thing. So we can draw our 2 carbon first and make sure each of our carbon bond to 4 other atoms. So as we can see here, this carbon bonds to 1, 2, 3, 4, and this carbon bonds to 1, 2, 3, and 4. So we know that's correct, and we can move on to the next one. For C3H8, the prefix would be prop. So we have propane. Now let's do the same thing when we're drawing. Let's draw our carbon atoms first and bond each one to 4 different hydrogen atoms, and then you can count at the end to make sure that it's correct. So as you can see, we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So that's correct. And for the last one we're going to look at, it's going to be C4H10, which is bute for the prefix. So that gives us butane. And we'll do the same thing when drawing it. We have, for this one, 4 carbon atoms, and we bond each one to 4 different atoms. And let's check again. So we have for this carbon atom 1, 2, 3, 4. For this one we have 1, 2, 3, 4. We have 1, 2, 3, 4. And then for this one we have 1, 2, 3, 4. So that's correct. So for the physical properties of alkanes, let's first look at the melting and boiling point. So the melting point, as you increase the number of carbon atoms, it increases the melting point and boiling point. Why does this happen? Well, this happens because the chain length increases, which increases molecule size and intermolecular forces of attraction between the atoms. Therefore, more heat energy is required to overcome and break the bonds. Next up, viscosity. So viscosity is the resistance to change into a gas. So viscosity increases as the molecules get larger, because an increase in boiling point and melting point means it's harder for the alkane to change state. And last thing we're going to look at is flammability. So flammability also increases as the molecules get larger. This is because as you decrease the number of the atoms, it increases flammability. Last thing is that alkanes are generally unreactive because they do not react with acids and alkalines because they have a single carbon-carbon bond, and each carbon atom is bonded to four other atoms. Next on, let's look at alkenes. So alkenes are unsaturated hydrocarbons, which means that the hydrocarbon has a double-double carbon bond. And the general formula for alkenes is C2H2N, where N has to be greater than or equal to 2. So let's look at how we do this. So first of all, the first one would be C2H4. So if we look back at our prefixes, for 2 we have eth. So we have ethene. Now drawing these are a bit more tricky because now we do have a double bond. So we would draw them like this. We have a carbon and it's double bonded to another carbon. And then we have 4 hydrogens. 1, 2, 3, 4. This happens because, as you can see, since the carbon has a double bond, it is bonded twice here, and then it is also bonded once here and once here. So you still have your carbon, which is bonded to 4 other elements. Let's do the next one, which will be for 3 carbons. So that's going to be propene. Don't worry if you haven't learned the prefixes yet. You can always just keep checking until you get the hang of it. So propene, we have 3 carbon atoms. So we're going to have 1, 2, and we're going to have a double bond between these 2. And now we're just going to have our hydrogens and add them so each carbon is bonded to 4. So we have this one, which is bonded to 4. And now this one, which already has 2 bonds here. So we only need 1 more. And then this is bonded to 2, so we add 1 and 2. Now let's just double check. So for this carbon atom, we have 1, 2, 3, 4. For this one, we have 1, 2, 3, 4. And for this one, we have 1, 2, 3, 4. So it still matches our rule, which each carbon atom has to bond to 4 other atoms. And lastly, we have C4H8. So that's going to be butene. And it's going to bond like this. See, with a double bond. And then we can do our other 2 carbons. And now we just make sure that each carbon atom is bonded to 4 other, that's not correct, 4 other carbon atoms. And that's how we get C4H8. So now let's look at the chemical properties. So in terms of reactivity, alkenes are more reactive than alkanes due to the double bond, and this double bond is easier to break apart than the single bond. And lastly, we're going to look at how to distinguish between alkene and alkane. So what we can do is add aqueous bromine to the solution. If the solution remains orange, it means you have an alkane, but if the solution gets decolorized, it means you have an alkene. Thank you for watching this video, and I hope you learned about the homologous series.